Hello everyone, my name is İclal. I'm a second year molecular biology and genetics student in Bilkent University. This is my Physics 102 lab final project experiment.
The name of this experiment is Exploring Electromagnetic Induction, Effects of Coil Density and Magnet Speed. The aim of this experiment is to study the use of Faraday's law of induction to examine the effects of coil density and magnet velocity on the induced electromotive force by measuring changes in voltage while a magnet passes through coils with different turn density. In this experiment, we're going to use the equation of Faraday's law of induction and also the equation of magnetic flux. We will also need the equation of velocity dependent on height. In this experiment, we will use coils with different number of turns. Here we have 200 turns, 400 turns, and 800 turns. And also we will use a magnet, a multimeter, the cables to connect it with, and a ruler to measure the dropping height of the magnet. There is two parts for this experiment. The first part will investigate the effect of number of turns on electromotive force. And the second part will investigate the effective velocity of the magnet on electromotive force. Now I'm going to move on with the first part of the experiment, demonstrated in lab settings with videos. Now I am dropping the magnet from the fixed height of 10 centimeters for different turns. I did it with first 200 turns, and then 400 turns, and then 800 turns. And now I'm going to demonstrate the results that I got. As you can see, for 200 turns, the induced EMF was measured as 13.6. And for 400 turns, the induced EMF was measured as 21.4. And for 800 turns, the induced EMF was measured as 50.1. These measurements have the error rate of 0.001 because of the multimeter's measuring error. Now I'm going to show the second part of the experiment. In this part, I'm dropping the magnet in the same number of turns all the time, but with different heights. First I did it with 5 centimeters, and then 10 centimeters, and then 15 centimeters. Now I will proceed with the datasheet. I have calculated the velocities from the heights, and then I filled the table with the data that I found in the videos. For the height of 5 centimeters, the magnet velocity is 0.99 meters per second, and the resulting EMF is 5.8. For 10 centimeters of dropping height, the magnet velocity is 1.4, and the corresponding EMF is 10.7. For the dropping height of 15 centimeters, the magnet velocity is 1.7, and the resulting EMF is 28.8. In conclusion, two important characteristics of electromagnetic induction have been proven by this experiment. First, as the number of turns of the coil increases, the produced EMF increases linearly. And also, as the magnet velocity increases, so does the induced EMF. Thank you all for listening to my project.